Welcome to the Explainer. All right, today we're going to tackle a problem that trips up a lot of people in algebra, multiplying two expressions like this. I know, it looks a little complicated, but there's a simple four-letter secret to getting it right every single time. Let's unlock the FOIL method. But first, I have a kind of weird question for you. What in the world do handshakes have to do with algebra? I know, it sounds a little strange, but trust me, this one simple idea is the absolute key to unlocking this whole process. Stick with me, it's all going to make perfect sense in a minute. Okay, so let's get into it. You've probably seen a problem like the one on the left before, right? Distributing that 2x is pretty familiar, but the one on the right, that's our new challenge. See, we're not just multiplying by one thing anymore. We have to multiply two whole expressions. So how do we make sure we don't miss any of the pieces? Well, we need a system. And that is where the handshakes come back in. The rule is super simple. To be fair, every single term in that first group needs to shake hands, or multiply, with every term in the second group. This makes sure that nobody gets left out. Our job is to make sure every single one of those handshakes happens. So, how do we keep track of all those handshakes without getting lost? Easy. We use a simple but really powerful tool called FOIL. You can think of it like a checklist, one that guarantees we make every single introduction and don't miss a single multiplication. Let's break down what each letter actually stands for.
Let's kick it off with F for first. This one's a piece of cake. You just grab the very first term in each of the parentheses and multiply them together. So in this general example, that's just A times C. One handshake down.
Next up is O, and that's for outer. For this handshake, you connect the two terms that are on the absolute outsides of the whole expression. So the one on the far left, A, gets multiplied by the one on the far right, D. Two handshakes done.
You can probably see where this is going. If we did the outer terms, now we got to do I for inner. These are the two terms that are smushed right next to each other in the middle. So B shakes hands with C. 3 down, just 1 to go.
And finally, L is for last. You take the last term from the first group, which is B, and you multiply it by the last term in the second group, D. And that's it. First, outer, inner, last. We have now systematically made all four connections.
But wait, don't stop there. There is one last, absolutely crucial step. You've got to clean up your work. After you've done all the multiplying, you need to simplify. And here's the secret. Almost every single time, the results from your outer and your inner steps will be like terms. That means you can combine them. This is the step that makes your answer neat and tidy, so whatever you do, do not forget it.
All right, enough theory. You know the best way to really get this stuff is to just see it in action. So let's work through a few examples together, and we'll start with a classic one.
Okay, here's our first problem, x plus 3 times x plus 4. Let's just run down our FOIL checklist. First, x times x is x squared. Outer, x times 4 gives us 4x. Inner, 3 times x gives us 3x. And last, 3 times 4 is 12. Awesome, we have all four of our pieces. Now, do you remember that final cleanup step?
Exactly. We have to combine those middle like terms. We got a 4x from our outer step and a 3x from our inner step. We just add those two together, and we get one single term, 7x.
And here is how all those pieces fit together to make our final answer. The x squared from our first step, that's the first part. The plus 7x we just put together is our middle part. And the plus 12 from the last step finishes the puzzle. Our final, beautiful, simplified answer is x squared plus 7x plus 12.
Okay, let's throw a little curveball in here, a negative sign. Now the process is exactly the same, but the key thing is that the minus sign has to stay with the 5. So for our inner step, it's negative 5 times x, which gives us negative 5x. For our last step, it's negative 5 times 2, which gives us negative 10. See? Then when we combine the middle terms, 2x minus 5x becomes negative 3x. You always have to keep the sign with its number.
Now you're going to want to pay close attention to this next one. It's a special pattern that you will see all the time in algebra. The terms look identical, a 3x and a 4. But look, the signs in the middle are different. One's a plus, one's a minus. Let's see what happens when we FOIL this. Our outer term is negative 12x, and our inner term is positive 12x. What happens when we combine those?
They are perfect opposites. The negative 12x and the plus 12x completely cancel each other out. They just poof.
they add up to 0. The middle of our expression just vanishes.
So our final answer is just 9x squared minus 16. That middle term is completely gone. This special pattern is called a difference of squares, and trust me, learning to spot this is like having a math superpower. It's going to save you so much time later on.
Okay, you are totally getting the hang of this. So now let's talk about the two biggest, most common traps that students fall into when they're using FOIL. Paying attention right now will save you a ton of headaches and probably a few points on your next test.
Okay, here it is. This is the #1 mistake in all of algebra. It is so tempting to look at x plus 3 squared and just think, oh, I'll just square each part and write down x squared plus 9. But that is totally wrong because it completely misses the middle handshake terms. Remember, squaring something means you multiply it by itself. So you have to write it out as x plus 3 times x plus 3 and then use FOIL. That's where that super important plus 6x middle term comes from.
And the second big trap is all about those sneaky little negative signs. Just like it says here, you have to watch them like a hawk. When you get to the last step at a problem like this one, you're multiplying a -2 by a -3. And what does a negative times a negative equal? A positive. It is so easy to accidentally write -6, but the real answer is +6. It's a tiny detail, but it changes everything.
So at this point, you might be thinking, okay, this is a neat trick, but when am I ever actually going to use this in real life? And that's a great question. So let's head outside to a garden to see a perfect real-world example of FOIL doing its thing.
This is so cool. This visual makes it all just click. Imagine your original garden is the first area, right? Its area is x times x, or x squared. Now you want to add 3 feet to each side. To find the total new area, you have to multiply x plus 3 by x plus 3. And look what happens when you FOIL it out. The x squared is your original garden. The plus 9, that's our last term. That's the little new corner piece. And the plus 6x, that's our outer and inner steps combined, is the literal area of those 2 new rectangular paths you added. FOIL doesn't just spit out an answer. It actually describes the physical pieces of the new area.
So there you have it. FOIL is your totally reliable system for multiplying binomials. It's just a way to turn a complicated-looking problem into 4 simple handshakes. But I want to leave you with one last question. We just learned how to put all the puzzle pieces together. But what if you started with the final picture, something like x squared plus 7x plus 12, and you had to figure out what the 2 original pieces were? How would you work backwards? Well, that's a challenge for our next explainer.